Okay. Good morning, everybody. Good morning and welcome to this fluid mechanics class. Hello. Yeah. So today we'll just brush up the second module. Whatever we have done, I'll just hint upon the important things, the important derivation, the important problems that you will be usually getting in your exams also. And I'll just brush through the second module once again so that it will be easy for you. Okay, it's a complete recap. Okay, one thing I want to tell all of you students is that these portions, what we are doing in the second module, will not be repeated again. First one. Second thing, whatever material we are giving you, either through Google Classroom or posting it on WhatsApp, please have that material with you, because for the second test, the portion will be module 2. For the first test, you already know whatever we have done previously in the classroom, that is first module portion, so that is fixed. For the second test, it is second module. So the material for second module I have shared with you in Google Classroom and also through WhatsApp. Okay, in case you need any extra study material, please ask me. I can supply, I can give you those material. Okay, regarding first test, it is module 1, for which you have done the portions in the class only. You have got the notes also. Okay, that is not a problem. Second module, it is through study material is given in both Google Classroom as well as WhatsApp. Okay, so with this material, you should be able to comfortably, you should be able to do the first and second test. Okay, this is for the information. So I'll just today I will just brush up the second module, and in the next class I will start the third module. Okay, so just brushing up. It's about fluid kinematics, the topic. Under fluid kinematics, you have two different kinds of motion, methods of describing the motion. First one I told you is called the Lagrangian method, where a particle is followed from the initial starting point to the end point, and its velocity acceleration are determined. Second, Eulerian approach. In the Eulerian approach, they take a cross section in the middle, at some point in the middle between the initial point and the end point, and at that point they will find the velocity and acceleration of the fluid particle. Now they have found it easier to be to follow the fluid particle in the Eulerian method. Hence, worldwide they use the Eulerian method, and it is very comfortable to understand the fluid particle motion. So Eulerian method is common and used everywhere. Okay. Then coming up to classification of fluid flow, how do you classify the fluid? First one is uniform and non-uniform flow. So the flow is known as uniform if velocity at any given instant is the same in magnitude and direction at every point. That means the velocity del V by del S is equal to 0 when time t is equal to constant. Now, for a non-uniform flow, del V by del S, that is rate of change of velocity with respect to time, is not equal to 0. Hence, it is called a non-uniform flow. Then we have steady and unsteady flow. In the steady flow, velocity, pressure, density may vary from point to point, but it does not change with time. That means del C by del T is equal to 0 at any given point, where C represents fluid characteristics like velocity, pressure, etc. And unsteady flow, del C by del T is not equal to 0 at any given location. Then we come to the most important kind of flow, that is laminar and turbulent flow. Now we know that for laminar flow, fluid particle moves along a smooth path or in layers, and it's later one other. And for a turbulent flow, it goes zigzag in a disorderly manner. Then we also spoke about the Reynolds. If Reynolds number is less than or equal to 2000, the flow is laminar. Now, this is a very important concept which you'll be using throughout your mechanical engineering course, the concept of Reynolds number. Hello, can you hear me, Sanjay?
Yes, sir.
Okay. If the Reynolds number is greater than or equal to 4000, the flow is said to be turbulent. Yeah. So this is the difference. Then we have compressible and incompressible flow. In compressible flow, we say that the density is not constant, whereas in incompressible flow density is constant. Okay. Then we have rotational and irrotational flow. That means the fluid rotates along its own axis. Then one dimension, two dimension, and three dimensional flow, which means that the fluid is flowing in x-axis direction for 1D flow, y-axis direction for 2D flow, and z-axis direction for 3D flow. Now, I think students, no need to chat. You can stop the chatting. If you have any work with me, only please attend the course. Then we discussed what is discharge. Discharge Q is equal to V by T, velocity by time. Okay. Then Q is equal to AV is called the continuity equation, where A is the area and V is the velocity of the fluid. Then we spoke about excuse me, the continuity equation. The continuity equation in 3D Cartesian coordinate system. Now, in the 3D Cartesian coordinate system, if we see the in the Cartesian coordinate system, if we see, then we have the equation for continuity equation, what it is called. Then we say that del x by del y plus del v by del w, del u by del x plus del v by del y plus del w by del z is equal to 0. It gives you the continuity equation in 3D Cartesian coordinate system. Okay, so that is the 3D Cartesian coordinate system. You will have to do the derivation. I have shared the material with you. Please go to the derivation. It is a very important derivation. They will definitely ask in the test also and also in the main exam. Then, if you take 2D Cartesian coordinate system, then the y component will go off. So you get del u by del x plus del v by del y is equal to 0, which is also called as a Laplace equation. If a fluid satisfies the Laplace equation, what do you mean by satisfy? If del u by del x plus del v by del y is equal to 0 is satisfied, then we say that there is a fluid flow or fluid flow exists. Then velocity and acceleration of the fluid particle. We spoke about the velocity. We said that if velocity in the x direction is u, velocity in the y direction is v, and velocity in the z direction is w, then the resultant velocity, capital V, is equal to ui plus vj plus wk. Now, why it is represented like this? Because it is a vector quantity. It has both magnitude and direction. Then I, j, k are the vector quantities. Therefore, the resultant velocity v is equal to root of u square plus v square plus w square. Then acceleration a is equal to v into del v by del s plus del v by del t. Okay. That is the acceleration. But usually they ask you to find the convective acceleration or the local acceleration ax, ay, and az. So ax is equal to u into del u by del x plus v into del u by del y plus w into del u by del z plus del u by del t. So what they are doing actually here, del u, del v, del y, these are all velocity components which we are going to differentiate. Okay. Then AX, AY, and AZ we are going to calculate. Now all these study material I given it to you. Please practice. Then streamline, streak line, and path line is it. So streamline is imaginary curve in the fluid across which at any given instant there is no flow. That is called a streamline. And many streamlines will form a stream tube. Then path line is a trajectory of a fluid particle and it shows the position of the particle at any given instant of time. Then streak line, it is a instantaneous picture of the position of the particle passing through the particular line. And I said, the example of a cigarette smoke coming out from the cigarette is a streak line example. Then we said stream function and velocity potential. So what is stream function? It depicts the streamline, and we said that the formula for stream function, that is psi, stream function is denoted by psi. Therefore, velocity in the x direction u is equal to del psi by del y, and v is equal to minus del psi by del x. Then we said that velocity potential denoted by phi gives the magnitude of velocity. U is equal to del phi by del x and v is equal to del phi by del y. That is the velocity potential. Okay. And we also did some problems on velocity potential and stream function. That is, if velocity potential is given, how to find stream function. If stream function is given, how to find the velocity potential. Also, I said that both these stream function and velocity potential are vectors. So they are given by equations. You will have to find the value of x, y, and z, or u or v, and then substitute that and find the stream function and velocity potential. Is there any doubt in this so far? These study material I given it to you already. Students, any doubt in this? Prayag, Jayant?
No, sir.
Hello? Any doubts? Are you understanding what I'm saying? Have you understood?
Yes, sir.
Okay, and all the study material given to you, correct? Is there in Google Classroom or you have it in your WhatsApp group, correct?
Yes, sir.
Have you opened the Google Classroom? Are you seeing this material, what I'm saying now?
Yes, sir.
Okay. So is there any doubt? Anybody?
None as of now. When I get a doubt, I'll ask.
Okay, very good. Okay. So then we say, I spoke about stream function and velocity potential. Stream function is given by psi. An equation is there for psi. So they'll give the equation in the problem. If they will ask you to find the velocity potential, at some point say x, y. Okay. And you can find the velocity potential at that point. Then what are the different types of motion? You have translation, and then linear deformation, angular deformation, and rotation. Now, what are these actually? As the fluid moves from one point to another point, there could be different types of motion happening to the fluid particle. First one, it could be translation. That means from one place, just it will move to another place. Or it could deform linearly, or angularly, a shear stress, or the fluid can rotate and come to the next point. So these are the four types of rotation. Okay. Then we have done some problems on the acceleration, velocity, and all that. Okay. Now today I will also give you some more questions. I will post it to the Google Classroom. Please see that you answer those questions and then send it back. Okay. Then we have done problems on acceleration, how to find acceleration, how to find resultant velocity, how to find the stream function, and how to find the velocity potential also. Now today I will give you some more problems. I will send you some more problems through the Google Classroom. Students, please see those problems and you complete those things. If you complete them, especially acceleration problems, I think you are not done. So I'll send those problems also. Please practice. Once you complete velocity acceleration problems also, then the second module is will be completed. Okay. So what I'm doing in today's class is I'm just going to rebrush. That is, I'm revising all the things that are there in the second module. See that you people get all the study material related to second module. Then it is very easy for you to attend the test also. Okay. So according to me, we have completed all the whatever is there in the second module. I will give you additional problems. Today I'll put it in the Google Classroom. Please see that you do all these, you go through all these problems. They're all solved problems only. Please go through all those problems. Okay. Yes, Jayan, Prayag.
Yes, sir.
Yes, sir.
That's in May also. Yes, any doubts, you please tell me. I given the assignment. Yeah, tell me.
No doubt, sir.
No doubt. Okay. I have given the assignments also. I had given some 4 questions. The assignment. Have you seen it?
Yes, sir.
I have given it in the Google Classroom. Have you seen it?
Yes,
Yes,
sir.
Try
sir.
to do it. Will you try to do it? Have you done it
Yes,
or
sir.
not?
Not
Yeah.
yet.
Please try to do those 4. Yeah. Please try to do those 4 assignment problems which I have given. Okay.
Yes, sir.
Okay. So first module, there is no problem because we have done it in college. Study material notes also we have done. So that is not a problem. In the second module, it consists of buoyancy, that is fluid statics, where we have a derivation of metacenter, metacentric height, then submerged bodies, buoyancy, flotation, conditions of equilibrium, stable, unstable, and neutral equilibrium, derivation of metacenter, metacentric height, problems on metacenter, metacentric height. Then afterwards, you have which one? Fluid kinematics. All these are coming in the second module. That is, it starts from fluid statics, that is a buoyancy, flotation, and metacenter. Then all those things. Then after that, you have fluid kinematics, where you have different kinds of motion. Then types of fluid flow, uniform flow, steady flow, 1D flow, 2D flow, and all that. Velocity, acceleration, stream function, and velocity potential. This whole thing constitutes the second module. Okay. And all this study material I have given to you. Please go through all those things. Also, you please have a video syllabus of FM with you. Then it's very easy. You can understand which topic comes in which module. Okay. Any doubts in this? Any doubts in this? Chinmay, Jayant, anybody?
No,
Prayag?
sir.
Okay. So you have understood what is the portions of first module, what is the portions of second module clearly, isn't it? Yes?
Yes, sir.
Okay. So study material also I have given. So in case you want any extra material, you can please put it in the group. Whatever is possible from my side, I can do. Okay. And one more thing, today I will send extra problems, additional problems on certain things. That is stream function, velocity potential, examination questions. Okay. I'll put some stream function and velocity potential examination extra problems. Also, I will give some problems on acceleration, velocity and acceleration calculation also. Okay. With that, that is quite sufficient. I'll give today about 8-9 problems extra, and I'll post it in the Google Classroom. Please go through that. Okay. If you do that comfortably, you can complete the second module. Okay. There should not be any problem in completing the second module. Okay. Yes, any doubts, anybody? Hello? Hello? Hello?
Yes, sir, no doubt.
No doubt, sir.
Okay, no doubt. No doubts. Okay. So I'll just send some additional problems and that will complete the second module. And I will start with the third module from the next class. So all of you, I think, should be comfortable. And additional problems on acceleration, stream function, and velocity potential, I'll be giving it to you through Google Classroom. Please go through that. That will complete the second module. Also, complete the assignment number 1, what I given to you. I have posted in the Google Classroom. All of you, please see the assignments. Assignment number 1. Actually, the due date is 9th. Okay, today is 7th, correct? Due date is 9th. Please see that you solve the problems and do the assignment number 1. And if possible, see other students, they are trying to post it in the Google Classroom itself. You also try to post it in the Google Classroom. Let us see how it is, how you can do the attachment, assignment, and see if you can attach it in the Google Classroom. If you can't, no problem, just do it and keep it, that's all. Okay, so if you do assignment 1, then module 1 is completed, module 2 also is completed, assignment 1 also is completed. With this, you should be able to easily do the first 2 modules. Okay, any doubts in this so far? Please ask any questions or doubts if you have any.
No doubt, sir.
Okay, so all of you are comfortable, right? Now let us see whether college opens on April 14th or we don't know. Any news from your side? Do people know anything about that one? Whether college is opening on 15th or postponed it is? Any idea? Anybody has got any information?
No, sir.
Okay, let's wait and see what happens. Okay. So
News
this
channels are
should,
telling that it
complete.
might get postponed, sir.
Yes, Chinmay?
News channels are telling that it might get postponed, sir. Not sure.
Yeah,
It might get
nobody is sure.
extended.
Yeah. Nobody is sure about that. Let's wait and see. Okay. So anyway, first module and second module are completed. As I told you, take care of derivations. Try to solve more problems and exercise problems, solve problems. Then you will be very comfortable in fluid mechanics. There should be no problem at all for you people in the first and second module. And also I given assignment 1 also. See that you do all these things, then it will be very, very easy for you. Okay. I don't think anybody is finding fluid mechanics difficult now, isn't it? You're all comfortable now. Okay. Isn't it?
Yes, sir.
Okay.
Yes.
In case you people have any textbook at home, fluid mechanics textbook at home, see the VTU syllabus, first and second module. Open the textbook, solve some problems on the topics that are covered in the first and second module. Then it will be very useful. You can do it. I mean, you get more confidence. You do more problems on stream function, velocity potential, more problems on meta center, more problems on what do you call this, velocity acceleration. When you start doing more problems from the textbooks what you have at home, then you will get more confidence. Okay, then it will become very easy for you people to continue. Okay, to understand also it's very easy. Please solve more problems. You are at home anyway. See that you complete this one. Okay. Any other things? Yeah. So with this, the first and second module is completed. Assignment 1 also I given. Okay. So I have just have some more time. So I'll just give the introduction to the third module. Okay. So the third module, I'll just start. The third module is called fluid dynamics. Okay. Now, so far, what are the things you have studied? Fluid statics. That means when the fluid is at rest, what are the forces acting? Then fluid kinematics. That means how the fluid flow or the fluid motion takes place. That is study of fluid motion. That is fluid kinematics. The third one is fluid dynamics. That means the fluid itself is really flowing. The fluid is flowing. Say in a dam, the fluid is flowing. Okay, the water is flowing. It comes to the dam. Then after the dam gets open, it comes outside. So the fluid is really flowing. This is real fluid flow. That is called fluid dynamics. Okay. So when a fluid is really flowing, then you will have to take into consideration the momentum equation. Momentum means the fluid is in motion. So whenever a fluid is in motion, what do we say? Newton's law, F is equal to ma. Force is equal to mass into acceleration. Therefore, a momentum takes place. So the mass of the fluid into the acceleration of the fluid. So the force takes place and then the fluid starts flowing. So we say that F is equal to ma, and beginning with that assumption or that formula, we do a derivation which is called as the Euler's equation. Okay. So once we calculate the Euler's equation, we derive the Euler's equation. From the Euler's equation, we derive what is called as a Bernoulli's equation. Now, Bernoulli's equation is a very, very famous equation in fluid mechanics. All the principles, major principles of fluid mechanics are all depending on they obey the Bernoulli's principle, or what is called as the Bernoulli's equation. Okay. So what is Bernoulli's equation? It just says that the sum of all the energies is equal to constant or it is equal to 0. Okay. Now what is the sum of all the energies? That there are three kinds of energies. What are the three kinds of energies? Number one, potential energy. Number two, kinetic energy. And number three, datum energy. Okay, these are the three things. So we're discussing about the three things. So three kinds of energy will be there. First one is called pressure energy. So it is due to the pressure of the fluid. Second is potential energy. All of you know, if it has some time, some head, then it is called potential energy. Then the third one is kinetic energy. Okay, so he is telling that the sum of all the three energies is equal to constant or is equal to 0. That means pressure energy plus potential energy plus kinetic energy is equal to 0. So this obeys what? The law of conservation of energy, which says that energy can neither be created nor destroyed, but can be changed from one form to another. So you can change kinetic energy into potential energy, kinetic energy into pressure energy, and you can keep converting energy from one form to another, but the sum of all the energy is always constant. That is called the Bernoulli's equation. So what we'll be doing usually is, I think next class we'll start with the momentum equation, the Euler's equation, and derive the Bernoulli's equation. And this is very, very important. And what is the Bernoulli's equation for fluid flow? Okay. So next class we'll be dealing with that. I will do the derivation, and also we can do more problems we can start the problems on Bernoulli's equation, derivation plus problem and all. Now, as far as the problems on velocity and acceleration is concerned, also stream function velocity potential, today around 8 to 9 extra problems. I will post it in the Google Classroom. Please go through that. Please go through that. And next class, I will start the third module. Today, I've just given an introduction to Euler's equation and Bernoulli's equation. Okay. Now, is there any doubt? Anything that you want to ask? Any questions, please, now. Gondraj, Shravan, Chinmay?
No, sir.
No, sir.
Okay. Is it very clear what I'm telling you?
Yes, sir.
Okay. Any other doubts? Yes, Sharan? Sharan, any doubts?
Sharon asked.
Any doubts, please? Yes? Smaran? Sharan, you raised your hand, that's why. Is there any question? Yes. Can you hear me? Can you hear me? Govindraj, can you hear me?
Yes, sir.
Hello?
Yes, sir.
Okay. So what we
Sir,
can do is, yes, tell me.
Yeah, you said you would send the notes via Gmail.
Which notes?
That
Not via
module 2.
Gmail. I said, yeah.
Hello?
Yes. Yes, tell me. What notes I have to send you?
Karana, go.
Sir, you said module 2.
Module 2, I have posted all the material on the Google Classroom. Have you seen? I have given all the
Actually,
material. Some half of the material I put in Google Classroom. Other half I put in the WhatsApp 4th semester group.
so that completely covers everything, sir.
Yes, exactly. That's what I'm telling. It covers everything.
Okay, sir. Thank you.
Hmm?
Thank you, sir.
That's not a problem. Otherwise, I can do one thing. Whatever is there in second module, I will send the whole thing as one. I will do one thing. Module 2. Okay, I will take that. I will call it as module 2. The whole module 2 study material, I will put it in Google Classroom. Okay.
Yes, sir.
That is okay, no?
Ye-
Then you will get
Yes, sir.
all whole second module in one place. Okay, I'll
Yes,
put it in the Google Classroom. The Google Classroom can hold so much material, isn't it?
Yeah.
It can hold, no? So many
Yes, it can.
MBs also, if it is there, it can hold. I think it should not be a problem. Okay,
Yes, sir.
I'll do one thing. Whole second module, I'll put it in the Google Classroom by today evening. Okay.
Okay,
So
sir.
you will have complete second module with you. Okay.
Okay. Yes,
Okay.
sir.
Okay. Then please do assignment number 1, which I have posted in Google Classroom.
Yes, sir.
Okay. Module 1 is not a problem because you attended the college. Notes and all is there. That is a different story. Only online I'm talking about now.
Okay, sir.
At present. Second module
Yes.
has been completed. Okay.
Okay.
Yeah. So if everything is done and if there are no notes, then we'll close the class. We'll wind up the class.
Yes, sir.
Yes. Okay.
Yes, sir.
Karun,